So on this problem, we want to find the cost function, the revenue function, the profit function, and the break-even point. We want to compute the profit or loss for 8,000 and 12,000 units. So we've got the problem where a pizza parlor has a monthly fixed cost of $5,100 and a production cost of $4 per pizza that's made. The pizzas sell for $9 each. So the first thing we want to do is we want to find our cost function. So a cost function is the C of x plus the f, where the C is the variable cost of each item made and f is the fixed cost. So in this case, our variable cost is our $4 per pizza. So it'll be 4x plus our fixed cost of $5,100. So that's our C of x. Our revenue function, which is our next part, is R of x is equal to the selling price times x. Well, in this example, our selling price is $9 per pizza, so it'll be 9x. So that'll be our revenue function. Our profit function, or P of x, is equal to the revenue function minus the cost function. So in this case, it'll be 9x minus the 4x plus 5,100. You want to put this in parentheses because you don't want to not distribute that negative sign to both. So this will equal 9x minus 4x minus 5,100. 9x minus 4x is equal to 5x minus 5,100. So that is our profit function. The next thing we need to do is find our break-even point. You can find the break-even point in two ways. You can set the C of x equal to the R of x because the cost equals the revenue, where you break even and you make a profit of 0. Or you can use your profit function to solve for your break-even point also. So we're going to use our profit function equal to 0, which means we break even and we don't make a profit, is equal to 5x minus 5,100. I'm going to add my 5,100 over to the other side. So I get 5,100 is equal to 5x. I'm solving for my x value here. So I'll divide by 5 on both sides. And 5,100 divided by 5 gets me 1,020 is equal to my x. So my break-even point will be 10, 20, and y is equal to 0. The next part that we needed to find was the profit at 8,000 and 12,000 units. So here we just need to plug in our 8,000 and 12,000 units in for our x. So this is up here in the top of our equation. So I'm going to use my profit function here, and I'm going to find P at 8,000. So P at 8,000, I'm going to plug it into my equation here. So 5 times 8,000 minus 5,100. So 5 times 8,000 will get me 40,000 minus 5,100, which will be equal to 34,900. So it would be a profit because it's positive. The P at 12,000 will be equal to 5 times 12,000 minus 5,100. So this will be equal to 60,000 minus 5,100, which will be equal to 54,900. So that would be the two values that we would need to locate on that.